chemical reactions. We are nearing the end of the unit, guys. We've got chemical reactions. We've got how to make chemical reactions faster and slower. And then we're done for new topics. So while you're watching this video, you should be split screening with your notes for chemical reactions, which you can just fill in right on your screen. And they've got all of the little information here. There's also these videos. They are on your notes as well as on my screen, but please watch the videos. Make sure you know what's going on so that you understand how all of this is working. All right, chemical reactions. How do we have those happen? We've talked about this since the very first day of chemistry when we said, like, how do we know if a chemical reaction happens? And we had lots of ways that we know chemical reactions happen. So we're just going to review that quickly at the beginning here. But let's start with some vocabulary that we may have talked about before, but didn't actually specifically say. So exothermic means that we give off energy. The energy is exiting, so it's exothermic, exiting the reaction. Endothermic, entering, entering, endothermic. So it's going to absorb the energy, it's going to get colder. So exo, exit, endo, absorb, or enter. So then you have spontaneous reactions, which means that they happen on their own, just poof. And chemical change means that you can't reverse it. It's probably the easiest way to have it explained. There are other ways that we have talked about it as well. So what is the general form of a chemical equation? So in grade 9, you need to be able to recognize a chemical equation. You need to know which side are the products and which side are the reactants, and you need to be able to name the appropriate chemicals in a chemical reaction. You do not have to predict chemical equations or chemical reactions, what's going to happen by looking at one side or the other. You do not have to balance chemical equations. You just need to be able to recognize the different types of chemical reactions, which is what we're going to do today. And then you need to be able to tell what it looks like. So this first one is just telling you, how do you know what a chemical reaction looks like when you do it with the formulas? So here we have our reactants. Our reactants are going to be on the beginning side of your equation. So as you read from left to right, the left side of your equation is going to be your reactants. Then, and they're connected by plus signs. Your arrow tells you that that's where the chemical change happened. This is what you start with. Then there's the change. So the arrow is the separation between the products, what you started with, the reactants, what you started with, and the products, what you end with. So over here, this is our product. The arrow always points to what you get at the end, the products, what you have made or produced in the reaction. So when you read this, if you look up here, you've got iron and. The and is the same as the plus sign. That's your word version between those two. So iron and oxygen yield. This yield sign is your arrow. That means chemical change has happened and you're making something new. We're yielding, we're making, we're producing the products, which in this case is iron oxide. Actually, it's iron 3 oxide, so that's actually written a little bit incorrectly. All right, that is generally the form of the chemical equation and what you need to know about that. Now, what are the indications that a chemical reaction has occurred? We have done this already. We know that color change, gas production, odor change, precipitate being formed, and the emission of energy, light, heat, sound shows us that a chemical reaction has occurred. We have done this from the beginning. So you guys are good on this, or you should be. Now, there's different types of reactions. And this is the new part that you need to know. So you need to be able to tell what the different types of reaction are. So the first one that we're going to talk about is the synthesis reaction. Synthesis and formation are the same types of reaction. It means you're going to put them together. Synthesize means put them together. So you're going to start with two elements. In this case, they're making your elements look like the skull and the hat, a little bandana. So you're going to have this by itself, and then it's going to have a chemical reaction at your arrow, and they're going to be put together in the end. So you start with element, and you get a compound. So if you go back to this one, this is a synthesis reaction because you started with two elements and you ended with a compound. That is how you can tell. Element gives you a compound. Synthesis reaction. So this is another way of writing it. In here, A and B, they're writing A and B because it could be any elements from the periodic table. So that would be your element symbols. You'd just have two of them separated by your plus sign, and then at the end, together. So combination reactions, they are usually spontaneous and exothermic. So here's an example, and you have circles on your note sheet that you can move over. So you've got sodium and bromine producing or yielding sodium bromide. And that is what you're going to have in the end. So that is your synthesis reaction. Element gives you a compound. Decomposition is the exact opposite of a formation. So formation or synthesis, you are forming. Decomposition, you are breaking apart. So instead of starting with elements and getting a compound, you're going to start with a compound and you're going to end up with your elements. So you're going to start with a compound, end with elements. There's your examples. These usually need energy. So they need some sort of heat, light, or electricity. So they are endothermic because they're sucking in that energy or they're absorbing that energy to have it happen. Here's an example. You're starting out with your compound. Aluminum oxide compound yields or produces two elements. Aluminum and oxide separate. Perfect. Decomposing. You're starting with one thing and you're getting smaller things after, breaking it down. Okay, those two are your basics. Now we get into a little bit harder ones. So single replacement means you're going to start with an element and a compound on one side of your equation, and on the other side of the equation you're going to have a new element and a new compound. So in here they're showing it with a broom, an owl, and a hat. I kind of like Harry Potter, so I like to think this is Hedwig, the broom, and the sorting hat. So you're going to start with the broom on its own. So this is your element, and your compound is the hat and the owl together. Then your new compound is going to be the owl and the broom. But then the hat is by itself. So that's the new element. So you're kind of replacing one thing as you go through. So here, I think these look kind of confusing, but you're going to start with one element. That element is going to go into the compound here, and this one that was in there is going to come out on the other side. So how you're going to know what this looks like, you're going to have zinc, for example, zinc here by itself. And then hydrochloric acid is going to make zinc chloride, and then hydrogen is going to be on its own. It's kind of hidden here behind my video, but it's hydrogen is on its own over there. So element compound, that's a single replacement. Upping the ante. Double replacement means you start compound, and you get two new compounds after. So here, these two together. So compound, and then we've switched. So in this case, you've either switched girls or you've switched guys. And why does that matter? It doesn't. except that you only get to switch one. And normally you either switch the cations or you switch the anions. And so they've decided to depict those as male and female. It really doesn't matter how you do it. But as long as you end up with, if it's an ionic situation, you need a cation and anion, cation, anion, new cation, anion, cation, anion. So this is your couples to start, and then you're switching here. This can also be talked about as dance partners. You're switching dance partners. Okay. So here you're starting with copper 2 chloride is going to hydrosulfuric acid, and then you get copper sulfide and hydrochloric acid. So you don't have to name all of them. All you have to do is recognize that if you have a compound and you get 2 more compounds, then you have a double replacement reaction. In grade 9, you just need to know what the different reactions look like. You do not need to know how to predict them. You don't need to know how to name everything. You just need to be able to say, oh, look, I have 2 compounds and I have 2 different compounds, double replacement. The last one that you need to know is combustion. Now, combustion is a little tricky, but everyone knows what combustion is because everyone's lit something on fire. A candle, maybe a fire pit, hopefully nothing else. So, in a combustion reaction, you need to take something, a hydrocarbon, and you burn it with oxygen, and you make water and carbon dioxide. So, how do you know if it's a combustion reaction? Keys. It has to have oxygen. You cannot burn anything without oxygen. And you will always get, for grade 9, water and carbon dioxide. Always. This over here, this is showing you a hydrocarbon, meaning that you have hydrogen and carbon in some amount, but you don't know what. And it doesn't matter. Sometimes there's an oxygen thrown into that compound. It doesn't matter. All that matters is that you've got this oxygen and you're producing water and carbon dioxide after, and this element has some carbon and some hydrogen in it. That's all you need to know for grade 9. So here's one where you've got ethanol burned with oxygen, gives you water and carbon dioxide. Okay, this is your basics. It says knowing the basics will help you predict. It will, but you don't do that in grade 9, so it doesn't matter. These are super simplified. This is grade 9. That's all you need to know. You may see these solid, liquid, gas, or AQ. AQ is a new one. It's called aqueous. Aqueous means it dissolves in water. You do that in grade 10. We don't do aqueous in grade 9. So if you see those, just know they're telling you what state of matter they're in. For you, it doesn't matter. Grade 9 doesn't matter. Just the basics. That's all you need to know. Now, you're going to go back to your chemical reaction notes. Well, hopefully you're not going back. You've been doing it all the way through. And you should be working on this summed up section.